Hello, my dear students. Today we can discuss Chapter 16 Probability of Standard 11 Mathematics NCERT textbook. What is probability? You have studied probability in your lower classes. Probability is the measure of uncertainty of various phenomena. That is, we are trying to measure numerically the things that we are not sure or that we are not certain. For example, in tossing a coin, we cannot predict whether it will show a head or a tail. We are trying to measure its probability, it's a chance. Okay, there are different types of probability. Like first one, statistical approach of probability or experimental probability that you have seen in your ninth standard. And second one, classical theory of probability or theoretical probability that you have studied in your 10th standard. And here we are going to see the third one, axiomatic approach of probability. Before seeing what is these three types of probability, we have to see the basic terms related to probability, like random experiment, outcome, sample space, events, etc. Okay, we can just see the terms. First, we can see random experiment. Random experiments, the experiment that we cannot predict the outcome. For example, in tossing a coin, we cannot predict whether it comes head or it comes tail. Okay, it should have more than one possible outcome. That is a random experiment. Two conditions: more than one possible outcome, and it's not possible to predict the outcome in advance. Other example, we can say throwing a die. We cannot predict whether it will show 1, 2, 3 or any number in 6. Okay, that is a random experiment. Next, we can see the term outcome. Outcome is a possible result of a random experiment. That is, in the experiment of tossing a coin, we can say outcomes are head or tail. And in throwing dice, outcomes are 1, 2, 3, 4, 5 or 6. Collection of all the possible outcomes of a random experiment is called a sample space, or we can say sample space is set of all possible outcomes of the random experiment. We denote it by S. For example, in the experiment of tossing a coin, sample space S is equal to X or T. And in the experiment of rolling a die, sample space is equal to 1, 2, 3, 4, 5, 6. Sample space is the set of all possible outcomes. In the experiment of tossing a coin, the possible outcomes are head and a tail. Like that, in the rolling die, all possible outcomes are the set 1, 2, 3, 4, 5, 6. Each element of sample space is called a sample point. Or we can say sample point is each outcome of the random experiment. 1, 2, 3, 4. All are outcomes of the random experiment. Or each element of a sample space. Anything we can define. So sample point is all that. And the last most important term is event. Event means some outcomes of the random experiment, or we can say it is a subset of a sample space. For example, in tossing a coin, we can say getting a head is an event, or getting a tail is an event. And in example of rolling a die, we can say getting a number 3 is an event, or getting a number less than 4 is an event, or getting an even number is an event. We can discuss more about the events in the next video. Types of events, algebra of events, etc. Today we can see more examples to understand these terms in more detail. Outcome, sample space, sample point and all. Before going to the examples, we can see what are the three important types of probability. First and second type you have already studied in your lower class, and third type you are going to study here. First one is statistical probability or experimental probability. Statistical probability or experimental probability is based on number of trials in an experiment. For example, if we are tossing a coin 10 times and it appeared head 7 times and tail 3 times, then probability of getting head is equal to 7 by 10 and probability of getting tail is equal to 3 by 10. That is, it is based on number of trials. And the second type is classical probability or theoretical probability. Classical probability is based on an assumption that the outcomes are equally likely. For example, we are assuming in case of tossing a coin, there is equal chance of getting a head and a tail. That is, the chance is 1 by 2. Equal chance. But here there is no equal chance in the first case. Or we can say in example of throwing a die, equal chance of getting each 6 numbers. 1 by 6 each. Here we use the term equally likely. We can say that we are assuming that the outcomes are equally likely. And the third type is that we are going to study in this chapter, axiomatic probability. Axiomatic probability is mainly based on axiom, mainly two axiom. That is, probability always lies between 0 and 1. This property holds for all cases, okay? 0 less than or equal to P of E less than or equal to 1. Probability always lies between 0 and 1. And the second axiom is if A and B are disjoint events, or if E and F are disjoint event, then P of E union F is equal to P of E plus P of F. Here one thing, E and F are disjoint events. E intersection F equal to empty. One condition, that is, if E and F are disjoint events, so that is its intersection is empty, then P of E union F is equal to P of E plus P of F. In a classical approach of probability, we have seen that in tossing a coin, probability of getting a head is equal to 1 by 2 and a probability of getting a tail is equal to 1 by 2. But here we can take even probability of getting head is equal to 1 by 4 and probability of getting tail is equal to 3 by 4. If we take these values, then it will satisfy the conditions of the axiomatic probability. We can see the probability is lying between 0 and 1. And here getting a head and getting a tail are disjoint events. Then here the union of this probability will be P of E plus P of F. This is the difference between classical probability and axiomatic probability. Okay, we will see this in detail in this chapter, axiomatic probability. Now we can see some examples to understand the terms outcome, sample space, sample point and all. First example, two coins are tossed once. Find a sample space. We know if one coin is tossed, then the sample space is set HT. Here two coins are tossed. Then we can see in the first coin it may show head. And in the second coin, again two possibilities, head or tail. That is, second coin may show head and second coin may show tail. That is, first coin head and second coin tail. Like that, in the first coin it may show tail and second coin again two possibilities. That is, it may show head or it may show tail. So these are the outcomes of this experiment. So we can write the sample spaces set of all these outcomes. Simply we can write, instead of h comma h, we can write hh, and instead of h comma t, we can write ht. Instead of this ordered pair, we can write th and tt. So sample space S is equal to, we can say hh, ht, th, tt. That is, first coin head, second coin head. First coin head, second coin tail. First coin tail, second coin head. And both the coins tail. Second example, find the sample space associated with the experiment of rolling a pair of dice once. Also find the number of elements of this sample space. Here a pair of dice means that is we are rolling two dice at the same time. We know the sample space in rolling one die at a time is set 1, 2, 3, 4, 5, 6. And rolling two dice, we can say we can write the outcomes in the ordered pair. XY say first element the number and the first die, and second element the number on the second die. For example, if the first die shows a 1 and the second die shows 3, we can write 1 3 like that. We can write all the possible outcomes. S is equal to set of all first die show 1 and the second die show 1. Like that, all cases with the first die 1 and the second die changing. Second case, first die 1 and the second die 2. Like that, 1 3, 1 4, 1 5, 1 6. First die with the 1 finished. Next, first die 2 and second die 1 2 3 4 5 6. 2 1, 2 2, 2 3, 2 4, like that. So this is the sample space. We can say S is equal to set of all xy such that x is the number in the first die and y is the number in the second die. Find the number of elements of the sample space. How many elements are this in the sample space? Here in the first row 6, second row 6, like that in the sixth row 6. That is 6 into 6 is equal to 36. Total number of elements is equal to 6 into 6, 36. Next example. In each of the following experiments, specify appropriate sample space. First one, a boy has a 1 rupee coin, a 2 rupee coin, and a 5 rupee coin in his pocket. He takes out 2 coins out of his pocket, one after the other. What's the sample space here? See, we can denote letters to this coin. Letter A denote the 1 rupee coin, B denote a 2 rupee coin, and C denote a 5 rupee coin. He is taking 2 coins at a time. So 3 coins 2 at a time. Therefore, total number will be 6. We can see S is equal to first coin 1 rupee and second coin 2 rupee, that is AB. Second case, first coin 1 rupee and second coin 5 rupee AC. And third, first coin 2 rupee and second coin 1 rupee BA. Like that BC and CA CB. We can say there are 2 cases with the first coin 1 rupee and 2 cases with the first coin 2 rupee and 2 cases with the first coin 5 rupee. And a second one, see, a person in noting down the number of accidents along a busy highway during a year. Number of accidents along a busy highway. It can be 0 or 1 accident or 2 accidents or 3 accidents, etc. So we can say S is equal to 0, 1, 2, 3, etc. Next example, a coin is tossed. If it shows head, we draw a ball from a bag consisting of 3 blue and 4 white balls. If it shows tail, we throw a die. Describe the sample space of this experiment. Here a coin is tossing. If it shows head, we are drawing a ball. And here we have 7 balls, 3 blue and 4 white. We can denote 3 blue balls by B1, B2, B3 and 4 white balls W1, W2, W3 and W4. And if the coin shows a tail, we throw a die. That is, outcomes we know 1, 2, 3, 4, 5, 6. So we can see the sample space. S is equal to, if it shows head, then we are throwing a ball. Then we have 7 possibilities. HB1, HB2, HB3. We have 7 possibilities. HW1, HW2, HW3, HW4. Or if the coin shows a tail, then we are throwing a die. There we have 6 possibilities. That is, if it shows tail, then either die show 1, or die shows 2 like that T3, T4, T5, T6. Here we can say HBID not head on the coin and a blue ball is drawn and like that HWI head on the coin and a white ball is drawn and like that TI is tail on the coin and 1, 2, 3, etc. 6 on the die. The last example. Consider the experiment in which a coin is tossed repeatedly until a head comes up. Describe the sample space. See here, if in the first toss head comes up, then we can stop. That is, we can take H. If in the first toss a tail comes, then we have to toss again. If in the second toss a head comes, then we can stop. Like that, in the first toss a tail, then a repeat again. In the second toss also tail, then again a repeat. Then if we got a head in the third toss, we can stop. Like that, the sample space will be S is equal to set H, TH, TTH, TTTH, etc. It will continue like that. So this is all about sample space and probability. In the next video, we can see events. Types of events are like a sure event, impossible event, a simple events, etc. And algebra of events are like event A or B, A and B, A but not B, not A, like that. And also mutually exclusive events and exhaustive events. Also we can see many more examples. So see you in the next video. If you find this video useful, please like, share, comment and subscribe to our channel. Thank you for watching. Thank you.